Good morning, everyone. On behalf of Vighyan Sarvatra Pujyate organizing team, I welcome you all for today's fifth day of this event. This science festival is now currently being held at 75 institutions all over India, including the Goa University. And it is being organized with an aim to celebrate the science for this entire week and to propagate it among the common man. Okay. I hope all the students and teachers present here today will have a great time with science. And so today's morning session will be include the talk by the speaker, and also a dance performance will be held. And after that, we will have an evening session wherein you will be given a science demo by Professor S.P. Kamath. And now I request our dignitaries, Dr. Sudhir sir, and to escort our today's speaker, Dr. Digambar sir, to on the stage. Okay, so today's our chairperson is Dr. Sudhir Cherukulapurat. He did his MSc in Cochin University and completed his PhD from University of Angers, France. He was optical engineer at Deposition Science Incorporation and was a research fellow at ICFO at Barcelona, Spain. He did his postdoc at University of Minnesota, USA, and later joined Goa University as a UGC faculty in physics department. He has several publications, and presently he is guiding his two PhD students under him, and has two projects running. I welcome you, sir, and kindly request you to introduce our today's speaker, Dr. Digambar sir. Digambar Parab.
Good morning and a very warm welcome to dear students, teachers and others. It's my privilege to welcome today's speaker for this session, Dr. Digambar G. Porab. Dr. Porab obtained his PhD from the Solid State and Structural Chemistry Unit, Indian Institute of Science in Bangalore in 2004. He then went on to do a postdoctoral research at the Department of Chemistry in the North Carolina State University in USA. He then returned back to India and worked in the R&D at the Global Research in General Electric India Technology Center, GE, for several years. He returned back to academia as assistant professor in chemistry at the Tempe College of Arts and Science, Miramar in Panjim. He worked there for 3 years, and presently Dr. Parab is associate professor at the School of Chemical Sciences at Goa University. Dr. Parab is a material scientist with 17 years of experience in solid-state chemistry, crystallography, and material development. He has obtained the GE's gold medal for filing 20 international patents, and he has published several papers in peer-reviewed scientific journals. I welcome Dr. Parab, and we are looking forward to hear your talk. So I hand over the mic to Dr. Parab. Thank you very much.
Good morning all. So this will be a very interactive session. So I expect all of you answer my questions and then we can move on. Okay, so I'll be talking about, lighting and display technologies, and let's see how much, you're aware of it and some more information you're going to learn when you go along. The first question to all of you, what is light? When you say light, what comes to your mind? I expect answers from you. What is light? Yes, anyone? Come on. Their mic, right? You see light everywhere. Without light, nothing goes. So, when you say light, what comes to your mind? What is the definition? How do you define light? Okay, only the first question I'll answer, the next you'll have to cooperate, okay? So otherwise I won't move forward. So it's electromagnetic radiation. Most important, it can be perceived by human eye. So that's what. There are a lot of, your long range electromagnetic radiation. What is perceived by your eyes is what you define as light. Now, this you should be able to answer. So what are the different sources of light you know of? Yes? Loud, yeah. Okay, light bulb, one of them. Yes? Sun rays, okay, sunlight. Then? Fire, correct, okay. What else? There are lots, come on. Lightning, okay, good. Yes? Sunshine, okay, sunlight, okay. What else? What are other things you know? This last benches, come on. We'll see, okay. Now if you see historically how the light evolved, at least in the Western world, okay. You started with a simple lamp, okay, your oil lamp. Then you went to candle. Then, I don't know how many of you have seen the third one? Yeah, okay, good. I thought only our generation only has seen. What is it? Not really. Okay. Actually, it is. I think your generation is not in. Petromax you heard of? You know Petromax? Okay. I don't know whether your generation has seen it or not, but our generations have seen. Next is your what? Yeah, incandescent lamp. What you have, filament lamp. Next is your regular bulb. Same thing, bit modified, sophisticated. And then your CFL. Okay. You have seen these different types of lighting technologies, what you get light. Now this is what you should think about. What way the above light sources are different? What do you think is different between them? What makes them different? If you think scientifically, or even in common perception, what do you think the difference? Yes, and I need a lot of answers from you. Okay, intensity of light, good, one. Then, next. What makes them different? Some more. Is the CFL same as your candle light? So. Sorry? Okay, it uses electricity. Good. What else? What else? What other things what comes to your mind? What are different things? This side quite. Yes. That side, any answers? What makes them different? Why they are so different? Yes, this side. Okay. One aspect we'll see, okay. One thing is, what we are worried is how much energy efficient Nowadays you would have heard, everybody is talking about going green, being more energy efficient. Okay. So when we talk about in terms of watt, okay. Now light is defined in terms of lumens. You might have another unit is also there for light. Anybody knows? For light, another unit which is used? Candela. Okay. So here we use lumens. So we are saying how many lumens per watt. Okay. How much is the light coming out for particular watt? Now this is equivalent to if I give if I tell you I give you 100 rupees, go and get some potatoes. Okay. You might go to a supermarket. You might get maybe 2 kg. I don't know. You go to a smaller shop. You might get for same 100 rupees. You might get 3 kgs of potato. Or if you go to a farmer, you might get 4 or 5 kgs potato. So that is what your input is the same. You are giving 100 rupees. What you are getting output is different. Here when you come, if you put 1 watt, okay, how many lumens you are getting? The traditional incandescent lamp or the what we have tungsten filament there, you could get almost like 16 lumens per watt. That was the efficiency. But the same 1 watt, if you are going to put for your CFL, compact fluorescent lamp, or linear fluorescent lamp tube light, you will get almost 70 lumens per watt. Now if you go further, what you have on the lighting, what you see, what are the lights you see here? LED lights, correct? So the LED lights you have, they have potential to go up to 300 lumens per watt. Currently they are around 150, 120, 150, but they have potential to go up to 300 lumens per watt. So this is what. So when we talk about scientifically what is the difference between them? Amount of light which is coming out. That is what has changed. Now if you look further, okay, how many of you have seen all these varieties, okay? Your incandescent lamp, your CFL, compact fluorescent lamp, your linear fluorescent lamp, you have the headlights of your vehicles, your sodium vapor lamp, your high pressure sodium vapor lamp, low pressure sodium vapor lamp, mercury vapor lamp, LED lights, and at the center, okay, you see so many different types of lighting sources are there, variety of them. So have you seen most of them or no? Yes? Okay. Now the question to you is, why so many different lighting solutions? This you have to answer. Can one thing fix all your problems? Why not just have one lighting solution does all the job? Why do you think we have so many lighting solutions? Think and answer. Do you have some answers? Questions? Anybody? You want teachers? You can answer. Why not just one solution? One simple thing? Even after LEDs, you have variety of LED lights. Why not just have one? Why so many variety of them? Okay, one is power consumption may be different. Fine, yes.
What should be eco-friendly? Everything, all those aspects are also very important.
Okay, eco-friendly. Okay. What else? Requirements are different. Okay. Quantify, requirements are different. Okay. They are different. Okay. Fine. Yeah. Agreed. We'll come to that. So what are these requirements? Okay. Yes, students, you should answer. This should come to you. You should ask why so many different types of lights? Why not just one single type light that should do the job? Why so many lighting solutions we have? You should be asking your parents, teachers, why so many different types of variety of lights? Why not just one single? Last benches, quiet. Okay, we'll go to technical details. Okay. Now, so this is called, for lighting studio. There are certain set of, items are kept. Different color items are kept. And what you do is, when you want to test a certain lighting, okay, solution, means bulb, tube light or anything, okay, which says lighting solution, you want to compare and see how do they work. Okay. Now what you see here, incandescent lamp is there, CFL is compact fluorescent lamp, your CMH is ceramic metal halide lamp, your mercury vapor lamp, low pressure sodium vapor lamp, high pressure sodium vapor lamp. So all these pictures, okay, items are the same, but when they are lit under different lighting solution, this is what you see. Why do you think they are different? You might have come across this when you come here, you see the color is different. You go to your lecture halls, colors are different. You go to shop, colors are different. You go to hotel, in the room, at home, things are different. What comes to your mind? What could be different here? What could be happening here?
It might be different.
Okay.
Even now tube lights also come in different colors. Some are yellowish, some are bluish, some give whitish. This
Okay, yeah,
light.
yeah. True, yeah, you're right on the track, yeah. I'll come to that in details, okay, yes. Anybody else? She's saying colors are different, okay. So what actually is happening here?
The material used inside may be different.
Okay, material used inside could be different, yes. Amount of light is different, okay, fine. And- okay, the way it is spread is different, yeah. Okay, low and high energy, okay, yeah. Some answers, come on. More focused, okay. Think. Interesting answers coming out. Okay, some more. This side, quite. I think they need light because they are gone to sleep, I think. The bulbs are not working there, I think. Okay, so let's see why the colors are different. So when you say white light, how many lights are there inside actually? What colors are there? 7 colors, right? So 7 different colors are there. Have you heard about complementary colors? What does it mean? Somebody can explain what are complementary colors? Anyone? Yes, can you give him the mic? Anyone? Everybody heard complementary colors, right? So what are those?
Intermediate colors or the different shades of colors.
Okay, not exactly. Let's see. Any other answer?
Or by mixing two colors,
Mm-hmm.
we get a different color.
Okay, not that side.
When any sample absorbs the light, we get to see a complementary color which is not absorbed, the transferred ones we
Correct.
see.
Yeah. So typically what happens is when you say something is green, something is blue, it is absorbing a particular color except the color what you see as a body. Okay, he's having blue color, mine is also light blue, she's having red, she's having green. So actually all other colors are absorbed except that color. So that's why you see the opposite color. And when you see this color, if you now, there are earlier days, used to get cards. Okay, you stare at a particular color, any of the complementary color, you'll see the opposite color. You look at that color, then for few seconds, look at a whiteboard. You'll see the bottom color, which is complementary. So that is, you'll see exact opposite. So it's always the one which is absorbed is not seen, which is not absorbed, opposite one is seen. So this is the principle which is very important when you come for lighting. Now, what is done is here. So if you see here, I hope you can see the picture is not really that good. I couldn't find a better one. Each one, okay. So color perceived when the material absorbs a certain regions of the visible spectrum, you can see. So if it is at 400 nanometer, which is typically blue, you can say, violet blue, you'll see yellow material. If you go to 450, which is between, blue and green, you'll see orange color material. If your material absorbs 500, you'll see the red. 550 onwards, your material will be violet. And if it is, like 600 and all, your material will be blue. This you can say, you might have seen copper sulfate. If you record a spectra for copper sulfate, you'll see, where it absorbs. So always the complementary one color will be seen, and this is where you'll know. Now, how do you use this information? Now, what is happening is, you have different lighting technologies are there. Now, first what you see on the topmost, sunlight, noon. Okay, this is what is important. Okay, I just wait for a second, let them settle. Okay, we can continue. So what you see on the spectrum on the topmost, okay, which is yellow noon sunlight. Okay, if you look at this spectra, what you'll see is right from 400 to all the way to 700 nanometers. There's a continuous contribution coming from the sunlight. Your sunlight at noon, 12 o'clock is such that every wavelength there's some contribution, nothing is missing out there. So that's why sunlight is, noon sunlight is the benchmark. That is the standard which is always taken when you want to see what is the light quality. Sunlight is taken as 100%, all these reference standard for it. Now when you have different technologies, you have now what I give you next is tungsten lamp. This is your incandescent lamp. Let them settle here. So incandescent lamp, which is 100 watt incandescent lamp, is the industry standard which is used for lighting. So if you are going to see any material, because you can't have sunlight all the time, you can't wait till noon to check what is color quality is. To replace it, what is done is 100 watt incandescent lamp is taken as a standard. The spectra what you see is very good compared to all other lighting solutions we have. So it has contribution starting from all the way to 400 going to 700, and because of the contribution in yellow, orange, red region is higher, you see that always the yellow color. So this is the next reference which is taken, which is really good. Now all other lighting solutions which have been tried to have. Okay, just wait. Yep. They missed out. This also. Okay. Yeah. So all other lighting solutions, what you have seen sodium vapor lamp, you have seen mercury vapor lamp, LED lights, CMH lamp. All these lamps, what are they are trying to do is they are trying to match this. If your spectra is such, whatever the lighting solution you are developing, if your spectra is such that it has contribution coming from all throughout 400 to 700 nanometer, then that is the best quality light you could have. Now you see your mercury vapor lamp. Where is the contribution? You see 500 to 600, you have 2 peaks there. That's all is what light is coming out. And anything you see is from this. If you look at your bar coding, scanning laser, it has only one wavelength. If you see the white LED, okay, this is what you have the LED lights. It has a contribution which is around 450, which is the blue LED chip which is there. Will come how it is actually done, how the LED light works, and then your contribution which is coming further 500 to 600 is contribution. But a lot of sections are there within the spectra. There's no contribution coming, or very less contribution is there. So compared to all other technologies, this is the best we have. White LED is the best next to incandescent lamp, and this is difference in the technologies you will see. If you have a look at here, what do we have? Incandescent lamp, you just have filament which gives you heat it at high temperature, and 100 watt is the best one. It is the industry standards for the light, but you have 12 lumens per watt. You come to fluorescent lamp, it is based on you need 2 components there. One is you need something which is exciting source. Okay, you have either mercury discharge is there which gives you 254 nanometer, and then you have a second material which is known as phosphor that converts this UV lamp radiation into the white light. Same concept is used compact fluorescent lamp, except that they could easily replace your earlier fixtures. And then we have the LED lamps which are using similar concept, except the excitation source is at 405 or 50 nanometer. Now you can correlate back to the pictures what we had. Now can you tell me why you have different colors now? Now I told you what is the technology difference. Now why do you think colors are different? Why do you see certain colors, you don't see certain colors? Yes, back to you now. If you understood, you can answer me now. Wavelengths are different, okay. Some more answers? Some answers from this side. Nothing came from this side. Yeah, light was required. You missed out on certain part, but still you can try to answer. So these are the pictures, same items under different lighting solutions. Incandescent light here, compact fluorescent lamp here, ceramic metal halide lamp, mercury vapor, low pressure and high pressure sodium vapor lamp. Okay, all are different. So effectively, the light which is input doesn't have that particular wavelength. If you see here, if a particular radiation doesn't have any contribution between say 450 to 500, it won't show those colors at all. If there is no contribution between 550 to 650, that particular color is missing from the light itself. So no way you are going to see that material, whatever it absorbs, it won't show the accurate color because those color components are missing from the material. So this is why each lighting solution is different, and the applications also differs because of that. What you use as a parking lot lighting, or you could use sodium vapor lamp, you can't use at home inside. You won't see any material. If you go to any shopping, when especially you're shopping for clothes, what happens is you just remember what type of light you had there. Those light will be different. The actual one they try to imitate sunlight, where all colors are seen. But in those shops you go where they use CFLs or linear fluorescent, you buy certain clothes, you come outside, you'll see color is different. You will think the shopkeeper has cheated. He has not cheated you. What is cheated is the light. Because if you use tube light to see the cloth color, it won't be same as actual. You have to come out in the sunlight, or you should have a 100 watt incandescent lamp or ceramic metal halide lamp. That is when you will see the actual color. So this is where application changes. When you come here, it doesn't matter inside lighting or home lighting, general lighting what we call it. It doesn't matter the color. It should be reasonably good. That's why you use CFLs, linear fluorescent. But it is actually not a good light to use when you want to differentiate the materials. So that much you should remember from here. Now comes the question. How do we quantify? I told you what happens now. All lighting solutions are different. Tube light is different. Your LED lights are different. Your incandescent lamp is different. But you can't say, you have to have some quantify. You have to quantify it. What way you can quantify? Give your suggestions. What can you specify? Okay, what are the specifications you can give for light? Saying that, okay, I want this particular type of light. How do you quantify it?
Amount of heat.
Amount of?
Heat.
Heat, okay. Amount of heat. And light, okay. Yes, some answers.
Different volts.
Different volt, okay. I want some more answers. Now the light is coming out. Now you have to differentiate. You can't tell that, I want a light which shows this color. You have to somehow quantify, right? Any item you quantify, saying that this is what light output, any item you'll have. You go to TV, you go to refrigerator, there are some specifications. You say, I want this. Or mobile. When you buy a mobile, you give a specification, right? You should have 2 GB RAM or 6 GB RAM. How much memory? So what do you specify here? How you quantify what light quality you should have? What could be your specification to say that this is the light quality I want? Brightness. Okay, in case of 1 linear fluorescent, I'll give 5 linear fluorescent. So will it do? Okay, we'll come to that. There are two terms when it comes to, when you go back home, if you have still a box of your bulb or tube light, you can look at it. It will have these two items, okay. One is correlated color temperature, okay. And second is, CRI, we'll come to that also, okay. Now this is nothing but a color of the lamp you have. Like madam just said, you have warm white, cool white, right? So this is one of the specifications which will be given. You might have seen in the movies or you might have seen in the Western world, they always at home, they are warm color, right? Yellowish color. Whereas in India, you see always blue tube lights. This is the difference. Europeans, northern hemisphere, they like colors which are warm, more sunlight type of colors. And this is one of the parameters you give. So you see from the base, what you see is 1000 to 10,000. So this is called, this is defined in kelvins, and I'll tell you what is this kelvins also. So this is actually temperature. If you take a black body, you heat it at high temperature, And at a particular temperature, if it is at 1000 degrees, 2000 degrees, 3000 Kelvin, what is the color of it? You know all, if you take any material, hit it around 500, you'll see that it is reddish color, charcoal, burning coal. Then you keep on hitting it, then all the up to 10,000 Kelvin. This is how you determine what is the temperature of the stars and all. So as black body is heated to high temperature, at what temperature a particular color is seen. So that same specifications are used here to define the light. So you would have your daylight at 6500, natural white 5000. Incandescent is the warmest one. You get a nice feeling in winter when you have the warm colors, and that's why it is so popular in the European world. Whereas us, we feel white is better, so we find that is called cool white. So this is one specification you will find. The second thing you will have is okay, this is what I was mentioning. So on a CIE chromatography diagram, you see the arc. What you see, it is a Planckian locus you will have. At a particular temperature, you will have certain particular color which is defined here. So we won't get into more technical details here. We'll stick to simple concept, at least as of now. Next, which is defining, very very defining parameter for your light is colors entering index, CRI. This nothing but it tells, it divides, as I said, 400 to 700 nanometer. You have the wavelengths. This defines how much of each one is there. Say 10% of 400, 10% of 450, 10% of next, in a range, particular range. And here at least the first 9 parameters, okay, these are very critical, and then you have up to 14, you are taking the average of it. And all this contribution, this will be considered as reference point. Sunlight is 100. This is what is taken as 100. Next comes, our human made next source is 100, watt incandescent lamp. That is what is industry standard to compare with. And when we have all these components here, then you say best of them is, if the your CRI is 100, you can say it is as good as sunlight. And any material color you take, if you light it within this, you will get actual true color. And this is what industry always tries to aim. Any new lighting technology, they are going to have two specifications. One is matching the color of the lamp. Okay, what is the color temperature? European, they need warm. Asian, they need cool white. Within that cool white and warm white, you should have CRI, which should come to 100. And this is where all the development work goes on to match it. Now, how do we achieve this 100 CRI? That is where I'll tell you. Okay, this is where the latest technology of solid state lighting comes into picture. Now, on the lower side, you can see two things, right? What are those on this side, left hand side? This corner? LEDs. All of you have seen LEDs. What do you see? Okay, don't say it is clock, but what phenomena do you see there? Fluorescence. You see fluorescence. Okay, what is fluorescence? Okay, not exactly. Anything, anybody else? What is fluorescence? I mentioned your tube lights, your CFL, they have fluorescence there. That's how they operate. No. Anybody? Fluorescence, you shine that material with a high energy radiation, UV, and then it emits, low energy radiation. That is fluorescence. Okay. In the case of, compact fluorescent lamp or linear fluorescent lamp tube lights, you have mercury discharge inside. It gets 253 nanometer, wavelength, UV radiation. That is converted to white light by the thin coating what you see on the tube lights. That is a phosphor which converts, and you get fluorescence. In the case of LED also, similar thing happens. So two components are important for solid state lighting. One is the LED chip. Second is you need a material which will glow. So your light emitting diode is nothing but a semiconductor light source that gives upon passing the electricity you get the light. And phosphors are the one fluorescent or phosphorus substance which glow on exposure to ultraviolet or visible light. Now this is how your LED bulb looks like. Pointer? No. Okay. But it's not. pointer. Okay. Now you see, this is how your LED bulb looks like. Okay. Heart of the bulb is this blue LED chip. So the LED chip will give you blue radiation. So earlier technology was, either you could use 405 nanometer or 450. Later all the companies went to 450 nanometer, chip. So this is the chip which is there. Over that, what you see here, is nothing but a phosphor material. This is the material which will absorb your UV radiation, convert into another radiation which is low energy, typically around 550 nanometer. And then you have the outer shield here, protection cover, and you might have seen in the torch. Okay, you have seen LED torch. What is the color you see at the center in the chip? Yellow, right? Greenish yellow. Okay, that is nothing but this material. Okay, yttrium aluminum, garnet it is called. Yttrium aluminate doped with cerium, and this is a garnet structure. And this is one of the most famous, popular, material which is extensively used for LED lighting. All the technologies which are there, this had a patent almost for 20 years. They are monopoly. I think just few years back they finished 20 years of patent, and that is now in open now. So this is the indium gallium nitride LED chip you would have, which will give you the 450 nanometer, and that is converted, part of it. Okay, what we do is we need the blue also component. We need blue, we need green, we need Zs. All the three component we need. So part of it is converted, and part of it is still intact. Okay, so it get transmitted, and this particular thing, it has emission right from 500 to all the way to 650. So this is enough to get you white light. You will get a white light, but it won't have the quality. This component is missing. There is nothing here. Okay, and you see this position, it is less. It doesn't have equal contribution. So the CRI, when we say define them, will be around 50 or 60% for you. It won't be 100. And all the lighting companies, what they are trying to do is improve upon this. Add some component here, add some component here, so that it can match. And those companies which are able to do it, they will have the bulbs in high demand, and they will make the money. So what we as a chemist do is we develop these materials. If you are wondering, why we are worried about this lighting technology, all these materials which are known as phosphors, chemist develops them. Okay, and we could come up with new materials, and you could have creating solutions for this lighting problem. Okay, any questions here? So as you see here, you have the blue, which is given by indium gallium nitride LED chip. You have the green, which is coming from YAG phosphor, and you could add any addition of phosphor, which is a red phosphor, and you could get 100 CRI. Okay. So far, any questions from your side? I have been asking questions. What is this one? Okay, phosphor is a luminescent material. Okay, when you shine, UV or radiation onto it, it will emit. It is going to emit a radiation in a lower wavelength. So if you are shining, say 400 or 450 nanometer radiation, it is going to emit anywhere beyond it, say 470, 480, all the way up to 600, 700 also. So there are phosphor materials which can emit even beyond that also, IR also. So these are the material. So what it has is, it is a parent phase here. You are doped with 1%, 2%, or even 5% with certain materials which are activators there. So dopant. So this is one class of materials which I extensively use. Okay, any questions, students, you have?
Any questions?
Then we move on to the next topic, which is display. So when I say display, what comes to your mind? Screen, okay. What else? Yeah, okay. What are different displays you know of? Lot of things, right? What you see is always on display. So what are those displays? What do you see? Tell me some applications, some items. So
Mobile screens.
Yes, mobile screen is a display. What else? Okay, LCD, what else? Projector display, okay. Yeah, okay, so many things are there. So these are the most common what you have, okay, your laptop display, your TV display, your mobile display, tablet display. But if you see historically, okay, what has happened? Have you seen the oldest one? What was it? CRT monitors, have you seen? Old computers, anybody? I don't know your generation has seen it or not. Have you heard of CRT monitors? No. Okay. You have started seeing right away LCD displays. Okay. So this display technology evolved over the years. Okay. So right now, okay, you heard about ultra high display, HD display, HDZD display. What are the difference? You have HDZD, True HD, 4K, ultra high definition. What are these? Number of pixels is different. Okay. What is different about the number of pixels? Correct. Number of pixels are different. So what is the difference there?
So SD ready has 780 pixels and SD higher SD at 1080p and all.
Okay.
It's different. It gets higher and higher.
More and more pixels. Okay. Anybody else? More clarity. Okay. Yes. Graphics. Okay. Now we'll come to this actually. What is, okay, as you said, more pixels are there. But how we are connected to lighting? Okay. If you want to generate, so this was your standard definition. Okay. This is the high definition. Full HD, ultra high definition, your 4K and 8K. So this is telling you how many pixels this is there. Okay. But now, if you want to have generate that many pixels, where you come is the CIE color space. So a particular color space, okay, you see this, these are the reg definitions, REC 709 and reg 2020 is the latest one. This defines, okay, these are the international bodies which defines, okay, when you call it HD, when you call it 4K, when you call it 8K. And if you want to have that many pixels, what you need to do is, this particular one, HD, the whole this space, color space, it is calling only 35% of it. You need to extend into deeper color space, and that is when you are going to get, you know, that colors. So in order to generate, you know, 2020 standard, you will have to have, you know, your phosphors, the materials which are used in your material for display is a phosphor material which shows you color. The color should be, you know, going towards green, which is, you know, for 535 beyond. You should have blues which are around 460, and you should have reds which are, you know, beyond, you know, here 650 or something. When you extend your color space around this dimension, that is when you can actually generate this different color space. Others you won't be able to generate. So this is where, you know, chemist comes into picture. What we develop is this phosphor materials which you generate those colors, and then you can get into, you know, display. So what you see when you buy a, you know, a laptop which is high definition, actually some of the materials which you develop are sitting there, which will give you that color. If you don't have materials, you can never have this high definition. Apple phones or Apple display which have, you know, high definition or ultra high definition need to have this type of materials. That is when you get. So this is the message you can take home. Now, what are some of the, you know, materials challenges? I'll give you in general. Okay, this was about your lighting and display. Just for you to know, as a chemist, what you can do in the future. Okay, I talked about your luminescent technologies. You can have LFL, CFL, LED lighting. You might have come across, you know, persistent phosphors, you know, glow in the dark. If power goes off, sudden emergency case, you can still see some emergency signage here. Then your various display devices, especially automotive lighting. Automotive lighting has changed drastically nowadays, and that has been possible due to new phosphor solution. You should also know, as a chemist, you know, you can develop variety of materials which are, you know, ceramic materials applicable You can get ceramic fabrics, metal composites, bulletproof vest, silicon nitride materials, and all other things. So this is what you should be aware that what chemist can do. Then you go to your batteries, lithium-ion batteries, or latest battery technologies. Chemistry is extensively involved. Your gas sensors, your fuel cells, your lithium-ion batteries, your sodium metal halide batteries. This is where your chemistry can help you. Your coatings where anti-icing coating. When you're flying by plane, there's typical icing issues. You could develop a coating where icing doesn't happen. You have materials which are self-healing materials. Your paint is getting scratched, it can heal itself automatically. If any coating is there, it is peeled off, it will heal itself. These are the self-healing materials. You also water repellent materials where water will never stick, just like lotus leaf, water never sticks. You could have these materials which have been developed. And these are IR reflective coating. Okay, when sunlight comes, only the light will come, not the IR radiation. It won't heat up. So these are the variety of materials which chemists are developing. You have the scintillators, you have the nanoparticles which are going for healing, and for this the CT scan use. This is the heart of this scintillators in the heart of the CT scan. You have different materials which are thermoelectric materials. These are thermal insulators. Nothing will happen to your flower even if you heat at the base. So that type of thermal insulators we have. Superconductors, I am sure you are aware of, nanomaterials. So these are the exciting class of materials which are available to you if you come to chemistry and do. Okay, that's all from my side. If you have any questions, you can always meet me later. We can discuss. Thank you.
So thank you, Dr. Parab, for the very interesting talk on lighting and lighting devices. So we have some time for question answers. So please ask some interesting questions. We'll be happy to answer you. I'm sure you have a lot of questions. Yeah, please come forward and ask. Don't feel shy.
Who has the question? No one? You all want to ask any questions?
Nobody.
This side. Any questions?
Which is the best light solution in household?
Yeah, you come.
So as of now, LED lighting is sufficient for the household solution. So if you look at the specifications which are given on the bulb, there will be 90 plus CRI, and that should do. So currently available.
Okay, so thank you.
I will ask one question.
Yeah, sure.
What is the future? Like now we have reached to LED.
Mm-hmm.
Any new source material of light which is researched on?
The lots they are trying to do, discharge lamps and all, but commercial making it available, and especially LED lights can last for 10,000 hours. That is what they are rated to. No other technology is coming close to it, but they are trying to have different solution. Even improving the incandescent lamp, they are trying to coat it with something optic and develop it, but still far away.
How to tackle the disposal of these types of bulbs and all?
Yeah, see, that is one of the major issues, and unfortunately government has not answered. And if you see, even the old, your CFLs, LFLs, government has no policy how to dispose them of. This is what is going to come. Many chemicals which are used in this LED technology. So for that particular matter, most of the new things, they could be very dangerous if they go out on outside. So this is where, maybe scientific community should ask government to come on board and have a particular, disposal policy in place. village by village. That should be done.
Can it be recycled or
Yes,
can be
definitely.
reused?
Yeah,
Is
it is possible. Yeah, it's
because many a
possible.
times lot of bulbs are getting means they are not working.
Yeah.
So can it be given somewhere?
Actually, I'll tell you a trick about LED bulbs. It goes bad even if one of the chips go away. So if you see on the YouTube, there are a lot of ways where they short it out, and then your LED bulb will start working again. So, but that's tricky. If you have some electrician, they can easily fix it. So many times at home we just bulb goes off, we throw it, but actually it's not necessary. You can just open from the top, check with see which one has gone bad, and it could be shorted, and you can continue using. That could be another business for somebody to reusing the bulb. Any other questions? Thank you.
Thank you, sir. I now request our chairperson, Dr. Sudhir C, to present a memento to our speaker as a token of appreciation. Thank you, sir. I now request Dr. Lectina Gonsalves to present a memento to our chairperson, Dr. Sudhir C. Thank you, sir. Thank you, Lectina. Okay, now we will have a short tea break, and all the students and teachers are present here are requested to kindly make their way to the cafeteria. Volunteers, please guide the students.
What about your final exams, huh? God knows.
Didi, you can say anything, but there is no breakfast for you.
Mama, please hurry up. I'm already late.
Coming. Vani, Akash is right. It will take some time.
But why, Mama? You know my school bus is going to arrive shortly.
I know, but...
Vani, don't worry. Take your breakfast after 1 hour. Do you know? All schools have been closed by the administration.
Yes.
Oh, really?
Yeah.
But why the schools have been closed? Is there anything serious?
Vani, have you noticed?
What?
The temperature is rising day by day.
Yes, Papa. But what is the relation between the two? Even rain was there on last Monday.
Not last Monday, it's raining since last night.
Oh.
Few areas have been flooded with water and not possible to drive on those roads. You know, schools have been closed so that the affected people can be accommodated there on precautionary measures. National Disaster Force is prepared for any contingency.
Oh, I didn't notice it. I was busy with my school project.
No problem. Don't worry. Now take it easy and have your breakfast after an hour.
But Papa, it has never happened earlier. It is too much hot with unseasonal rain. Difficult to believe.
Yes, Akash. It's all due to global warming and climate change.
What do you mean by climate change?
Yes, Papa. Even my teacher was telling the same. Many countries are under its influence.
What are the reasons behind this, Papa?
Enough. First have your breakfast.
Okay, Mama, but it will be better if both can go hand in hand.
Yeah.
Listen, air and water are two important constituents of our environment. Long-time changes in the environment fall under climate change. These can be natural or man-made factors. After Industrial Revolution, the average climate conditions have changed and world temperature is rising. Sea level is rising and many living species are on the verge of disintegration. You understand?
Yes, Mama. Our ma'am was also telling that the causes behind natural disasters in Jammu and Kashmir, Kedarnath, Tamil Nadu and Kerala were due to climate change.
True.
But Mama, how did they happen?
Vani, See, we human beings are the main culprits. In nature, the process of change is very slow, but it's all due to deforestation and excessive exploitation of resources that causes all these blunders.
Mummy, I had learned that even polar ice is also melting at fast rate.
True, Akash. Absolutely right. During last 100 years, Antarctica temperature has risen almost double. Its snow cover is depleting day by day. It affects the lives of living organisms that found in the Antarctic region. If it continues, then I think by the end of this century, 80% snow cover of Alps mountain may disappear.
Oh God.
Yes. Our own glaciers in Himalayas are melting at very fast speed as compared to other regions.
And you know, kids, due to global warming, the ice and snow of the glaciers and the Antarctica melt at faster rate.
Oh.
This raised the sea level. On an average, the sea level has been raised by 27 centimeters.
Oh.
There is a danger that low-lying countries like Maldives may be submerged under seawater in near future.
Oh
True.
God.
Very true. And remember, the rising level of carbon dioxide in the atmosphere cause change in our ecosystem. You know, the acidity of seawater is rising. It changes the living organism patterns, and moreover, the carbon absorption power of the ocean is reducing day by day.
Correct.
Increasing pollution means change in biodiversity and the ecosystem.
If these changes continue in future, means more and more disasters.
True.
A change in temperature up to 1 or 2 degrees Celsius will change the pattern of agriculture production.
And we are witnessing this.
Green pastures covers may be reduced and water availability may be affected.
Right.
Okay.
This will lead to human refuge from one place to others.
True. And you know, due to mass scale migration, the demography of many regions may change, which means change in social setup. The social disturbance will cause disharmony and unrest in the society. Shortage of food and scarcity of available water may cause worldwide unrest and violence. India, Bangladesh and China may be the most affected countries in the world.
Really?
Yes. In one UN report, it is said that in coming years, the weather change and global warming will drastically change the future world.
And you know, kids, effects of climate change will be reflected throughout the world.
True.
India can't remain aloof.
Yeah.
Right.
Due to global warming, we shall face many problems. By an estimate, it has been predicted that temperature of Indian subcontinent may rise up to 4 degrees Celsius.
4 degrees Celsius.
But who predicts these changes? And how are these predictions made?
Vani, it is all by the Department of Meteorology.
Oh.
Indian Space Research Organization collects data from the weather satellites launched for this purpose. It has been predicted that the sea water in our region is rising at the rate of 2.5 millimeter per year. If it continues, it is estimated that by 2050, the sea level will rise by 15 to 36 centimeters. Low-lying areas like Sundarban may be submerged under the seawater.
True, very true. And you know, due to greenhouse effect, the average temperature is actually rising. By one estimate, it has been predicted by the scientists that the average temperature of the world during 2020 may surpass the temperature of last 1000 years.
Oh my God.
Yes. The 1995 report of Intergovernmental Panel on Climate Change said that if the present situation continues by the end of 21st century, the global temperature may rise by 3.5 to 10 degrees Celsius.
True.
The report says that the greenhouse gas effects has already begun and it's now clearly visible.
Yes.
But Papa, is India too going through these changes?
Yes, Akash, no country is safe.
True.
Those countries where monsoon brings rain may be affected by heavy rain, drought or flood or soil erosion or something else. You know, quality of water may not be the same and even its availability get reduces.
Yeah.
It is said that the rainfall in middle and northern India will fall and that of eastern and southwestern India will rise.
Oh.
This means drought in some parts
and floods in other parts.
Correct.
Now I understand. This was the reason of last year's flood in our city.
Right, it may be possible. Under these conditions, our agriculture will be drastically affected. Availability of drinking water will be reduced. Water will get polluted, and moreover, the distribution of water will be affected. And in some parts of the world, like Southeast Asia, water will be available in abundance, but in Central Asia, its availability will be scarce.
But will the countries lying on the seashores also be affected?
The effect of rising sea level will be felt up to 60 kilometers from the shores.
60 kilometers?
Yes, 60 kilometers. In Bangladesh, the Ganga Brahmaputra Delta, Nile River Delta in Egypt, Marshall Islands and Maldives Islands will be submerged under sea water. Can you imagine that?
Oh God, it's scary. Well, in India, many parts of Odisha, Andhra Pradesh, Tamil Nadu, Kerala, Karnataka, Goa, Gujarat and West Bengal may submerged under seawater. And about 10 crore people maybe get displaced, and many parts of Lakshadweep and Andaman Nicobar Island may get lost underwater.
10 crore.
Yes.
Can you imagine, kids?
Crore.
It's not a small figure.
Yes. And this will also reduce the availability of fresh and drinking water.
Not only this, it will also affect the biodiversity of sea corals and seaweeds.
True.
Which are commonly known as the tropical rainforest of the oceans. Rise in temperature will also affect the microorganisms of the seas and the oceans. They may get lost from some regions. In 1997, a substantial portion of Pacific Ocean coral reefs and other weeds and many other species were affected. By an estimate, it is found that 30% coral reefs are drastically affected.
Yes.
10% were killed and about 30% have degeneration. Global Coral Reef Monitoring Network of Australia has reported that by 2050, most of the coral reefs may disappear from the global face.
It's going to be very sad.
Papa, are the fishes also going to be affected by the global warming? They are water creatures after all.
Yes, Vani, there is no doubt in it. By the way, I have to leave now. Okay?
Okay.
But Papa, you still not answered my questions.
I will answer all your questions in the evening. But now I have to leave.
Papa.
See you in the evening, kids. Bye-bye.
Bye, Papa.
Bye.
Mama, even you know about all this, right? So please tell us.
Yeah.
Okay. What is your question?
Didi has asked about the effect of global warming on fishes and other living organisms in the oceans and seas.
Yeah.
Good question. See, in one study, it has been reported that global warming is drastically affecting the lives in Caribbean region. Scientists from the University of Florida have reported poisoning of fishes in the Caribbean. The poison passes to human being through food chain, resulting many diseases and physical disorders.
Diseases in fishes?
Surprised?
Yeah.
Akash, Professor Maurice has reported that due to rise in sea temperature, some species of algae are showing intensive growth, and many of them are poisonous in nature. And as fishes in seawater survive on algae and seaweeds, right? So hence they are forced to eat these poisonous species, thus they too got poisoned.
But Mama, how is it going to affect us?
It's simple, Vani. When man eat these fishes, his body too get contaminated with harmful and polluted elements. Got it?
Yeah.
Okay. So the poison that found in fishes is very harmful and sometimes become fatal. Even after proper cooking, it still persists in the food. So many people are reported with fatal diseases such as cancer.
What a nexus.
Yes.
Fishes are getting poisoned and those who eat them too suffer.
Yes.
Thank God that we are vegetarians.
But Mama, what about others? How do we come to know about all of them?
There are some common symptoms. People start vomiting and feel dizziness. Diarrhea is also observed in some cases. In some serious cases, the patients start shivering and have intense body pain.
Oh my god. Mummy, it is really frightening.
It is.
But are there some remedies?
Well, experts are of the view that first we should try to know about the main elements that cause this. It's none other than but global warming and weather change. It will help us to protect our environment as well as our biodiversity. Akash, go and open the door.
Yeah. Papa, how you are so early?
Hi.
What happened?
Nothing. I have come early to pick you all with me for a workshop on disaster management.
Oh, wow.
Are you excited?
Yes, Papa.
And you know, experts from different fields are coming to give their presentation.
Oh, that's so wonderful.
So let's get ready fast because we have to reach there in an hour.
Okay, come on.
Get ready. Let's see.
Yeah.
Namaskar. Welcome all of you in this special workshop on managing and understanding climate change and global warming. To explain more, the experts with us on dais are Dr. Anand Sharma, Deputy Director General, Indian Meteorological Department, Dr. Somnath Vaidya Roy, Associate Professor, Atmospheric Science Division, Indian Institute of Technology, Delhi, and Dr. Sudesh Yadav, Associate Professor, School of Environmental Science, Jawaharlal Nehru University, New Delhi. Thanks. Dr. Anand Sharma, what are the negative impacts of climate change and global warming?
Nowadays it is said that global warming is happening. Global warming is going on. The climate is changing and it has many consequences. Many places will be dry, agriculture will be affected, food security will be affected. Many kinds of diseases can spread. Due to the rise in temperature, people may face shortage of water. Many species may go extinct.
Okay, how can we minimize the impact of climate change and global warming?
To check all of these, two things are important. One is mitigation and the other is adaptation. As far as the question of mitigation is concerned, some countries have been reducing their greenhouse gases. India has also reduced. Carbon emissions should be zero. Solar panels should be installed. Water harvesting techniques should be encouraged. Lifestyle change is very essential. Somewhere, we have to change our mindsets.
Dr. Sudesh Yadav, I would like to ask you that India is a developing country. How is government planning to reduce the impact of climate change?
India is committed to reduce climate change impact. It has made schedules, planned own programs. Being a developing country, India has asked the developed countries to tell their rules, explain their plans, and how they would start it from 2020. As far as India is concerned, it is committed for this, and our government is working on it. Let me give you an example. We have to invest 2.5 lakh crore rupees to achieve the 2020 target. The government has decided to generate more than 1 lakh megawatt of energy from alternate sources, such as solar energy, wind energy, etc. 60,000 watts is from wind power and 40,000 watts from solar energy. So we are committed to it. And we've turned towards nuclear energy too, so that the dependency on coal for production of electricity can be reduced. By doing this, the emission of carbon dioxide, sulfur dioxide, nitrogen oxides are reduced. All of these create pollution and global warming.
Dr. Sudesh, how people and development are connected? Please tell us.
In simple language, development means to make more things and to make good things, better things. So development will have to keep going. And when you make things for development, population, people will also be needed to consume them. So population and development are connected. When you develop, you need a place, you put up an industry. If we do action, then environment is also added to it. So nowadays, there is a need for sustainable development. Using a resource and becoming a resource are two different.
Yeah. Hello. Judges of the competition may kindly please, take the front seats. All the judges, Sagar, Megnath.
Hello all. Now we will have a dance performance, cultural dance performance by V Vibes group from Mapsa. Yeah, you can come. Thank you for the lovely performance. I now request Dr. Lectina Gonsalves to present the memento to the group members. Thank you. Now we will have a scientific movie from Vighyan Prasar.
सांग हय उलयता म्हणटा येता खंय रे येता खंय येतले खंय हय येतले खंय हय 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 सिंगल 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 हय सांग कितें म्हाका खंय खबर हांव खंय मेन निखील न्ही रे सगळे ना ताणें म्हाका सांगलें फोन मार ताका उलयता हेका तो फोन मारता म्हणटालो म्हण तुका हय तूं फोन मार ताका बरें बरें
Installed solar panels, and I was going to grow crops here, but short of time I wasn't able to. And to cultivate and all, he uses robots. And when science will reach every single corner of India, it will be just new India.
वर्ल्ड चेंज केलें जस्ट 3 नंबर केले इन्वेंशन ऑफ झिरो एंड देन मेडिकल फील्ड ते एक्चुअली कोणाक खबर सुद्दां ना इंडियन असे सायंटिस्ट जावन गेल्लेले आहा ते लायक खुबशे यूथ आहा तांकां आजून खबर सुद्दां ना की तेंच्यांनी कितें कंट्रिब्यूट केलां टू द वर्ल्ड लायक आतां आयन्स्टायन एंड ऑल ते कॉमन जालां लायक खूबच कॉमन जालां की ओके तेंच्यांनी इन्वेंट हें केलां लायक एटॉमीक थियरी कोण चिंतूंक शकना की एटॉमीक थियरी त्या टायमार जाल्लेले आसले एक फिल्डार आसलेले बनियन ट्री है त्या टायमाचे एक सायंटिस्ट जाल्ले बट तेंचे आतां कांय सायंटिस्ट कोण सायन्स डे जाले नो कोण आनी आसता थोडे खबर जस्ट कळपाक की ओके आमचे बी कोण इंडियन्स आसलेले आय कॅन न्यू इंडियन लायफ कल्चरल ट्रेडिशन एक्चुअली हांवें ड्रॉइंग करता रिसर्च केलें म्हणून ट्राय कळ्ळें म्हाका खबर ना
people are dragged by a certain thing. Therefore, what do they want to tell us now?
We have to take a snap. So we'll click a snap for all the participants and the judges. So I'll tell them to gather on the stage now.
Okay. Happiness.
Now, this has got three major advantages. The first advantage is that if we use less quantities, less expenditure. Okay. The expenditure is so less that it can be less than a rupee. That means if a normal experiment requires say 100 rupees, by using the quantities which you are going to, yes, that is enough, don't make it more, yeah. By using the quantities which you are going to use today, if that much quantity, the expenditure is scaled down from rupees 100 to 1 rupee. Okay. But on normal scale, less than 10 rupees expenditure, we can do these experiments. Okay. Instead of 100 rupees, we are doing less than 10 rupees. So that is the first aspect. Number two, many a times in chemistry, what we do, after carrying out the reaction in a test tube or in a beaker or whatever that is, we throw it into the sink. Where does it go? It goes into our surroundings or environment. So that is polluting the environment because they are chemicals and that is a waste. This is not allowed abroad in many countries like USA, Europe, etc. The waste is to be collected in separate containers and then it is to be disposed, which is not there in India. So by carrying out micro scale experiments, we use less quantities, therefore the waste generated is also less. Naturally, if we are using very less quantities, naturally the waste generated will be very less. The third advantage is there is no pollution or pollution is negligible, okay, because the waste is decreased. If waste is decreased, pollution is negligible. Not only the pollution because of the waste, but pollution due to the chemicals. When the students are working, sometimes there are compounds or there are solvents which are giving vapors which are not good, which are harmful. So naturally, if that is quantities are reduced, those vapors will get reduced automatically. And many micro scale experiments do not require a lab. You can carry out those experiments anywhere. You can see now today we are going to carry out these experiments here. This is not a lab. Okay. So that these are the most important advantages. In addition to this, there are many, many more advantages. Now, I don't know, Dr. Lektina, will there be prizes for the questions? Yes. Okay. How many questions? 5 questions. Okay. I'm going to ask you some questions. Before that, I will give you a small intro. Okay. And based on that intro, I'm going to ask you some questions. And these are prize-winning questions. There will be a prize. But listen here carefully. How to answer these questions? You have to raise your hand. All of a sudden, you should not shout the answer. You have to raise your hand. Then I will say yes. You answer.
Prizes after some time.
Okay, no problem. No problem. You have to raise your hand. Then I will say, give your answer. If your answer is correct, you will get a prize. If your answer is not correct, then somebody else can give the correct answer, or I will tell you the correct answer. Is that okay? The experiments are related to pollution of air. I think all of you are aware of this, pollution of air. Okay, how does this air pollution takes place? Especially by different gases. Okay. Now, there is a common observation. My observation often is that if I ask you a question, which gases are responsible for pollution, then immediately the students say carbon dioxide. Okay. Carbon dioxide is, but not to the extent which other gases are. Okay, there are some more gases. Answer I am not going to give because you have to tell me the answer. Carbon dioxide is not that bad pollutant. Why? Because it is taken up by the trees and it gives us oxygen. Carbon dioxide is taken by the green leaves, and during photosynthesis, in presence of light and water, we get carbohydrates being prepared in the leaves and oxygen is being released. So it is not that dangerous. It is dangerous only because it causes global warming. Why it causes global warming? Because carbon dioxide absorbs in the infrared region. I hope you understand. Visible region is there, okay, infrared region is there, ultraviolet region is there of the electromagnetic spectrum. Infrared region has got heat. I don't know whether some of you have observed, if somebody has got a sprain, etc., then he is given infrared radiation. It is hot, okay. So it absorbs in the infrared region. That is the precise reason. If there is more carbon dioxide in the atmosphere gets heated up, okay. So it is responsible for global warming, and there are many bad consequences of global warming which I am not going to tell right now. So carbon dioxide is a pollutant, but I don't want answer of carbon dioxide. You can tell me other gases which are responsible for pollution. Okay, so my first question is, which are the major gases excluding carbon dioxide which are responsible for pollution of air, okay, that we breathe? Raise your hand. Okay, yes? Carbon monoxide. Okay, no problem. But carbon monoxide, you are absolutely right, carbon monoxide is responsible for pollution, but carbon monoxide, can you tell me how it is formed? Huh? Car exhaustion, carbon dioxide is also formed, but how carbon monoxide is formed? Can you answer that question? Huh? No. Smoke means carbon particles. Smoke is carbon particles. Smoke is not. We normally say smoke means carbon monoxide, carbon dioxide, but it is mainly carbon particles. That is why if a ray of light passes through your room, and if there is some dust or if there is some smoke, you can see it. That is because of the Tyndall effect. Okay, anybody else? Yes. Oh, no, I'm not happy. I want the gases which are really responsible for pollution. Yes? Huh? Sulfur dioxide. Yes, you are right, absolutely. Any other? Some more gases? Wait. Huh? Nitrogen dioxide. Yes, very good. So, she is going to get the prize. So, nitrogen dioxide, nitric oxide, nitrogen dioxide, we commonly call it as NOx. So that is responsible for pollution. Similarly, sulfur dioxide and sulfur trioxide, they are mainly responsible for pollution. We call it as SOx, SO2 or SO3. Okay? What's your good name? Which school? Okay, good. So we have answered this question. Okay. Now we are going to proceed further. What are the sources of these polluting gases? This is the next question. What are the sources, from where they come? For example, now she told nitrogen dioxide, sulfur trioxide. Yes, please. Huh? Combustion of what? Combustion of gas? No, that's not the correct answer. Combustion of what? Yes, can somebody rectify it? Volcano eruptions, yes, but that is to a small extent and is limited to only those places where there are volcanoes. There is only not all gases, but some gases, especially sulfur dioxide, sulfur trioxide can come from this. Industries, yes, that is true. Yes. Industries, okay. Huh? Factories, industries are one and the same. Yes. Huh? Yeah, for that matter, if you burn not only plastic burning is not good. That is going to give many harmful gases. Any burning is going to produce carbon dioxide. Somebody answered carbon monoxide also, but I asked when carbon monoxide is produced, incomplete combustion is going to give you carbon monoxide. If there is no sufficient oxygen, then carbon monoxide is formed. So these two are always formed by burning, any burning, burning of wood, burning of leaves, burning of forest. But people have not answered the question properly. She said burning. Okay, she said burning gives these gases, that is the source. But what is that is burnt mainly, and nobody has answered. Everybody said industries. How you have come here? You have used by a bus or a car or a scooter, no? Vehicles are the major pollutants today all over the world. Okay, leave aside the industries. Vehicles are the major pollutants and they are responsible mainly for the pollution of nitrogen dioxide, nitric oxide and nitrogen dioxide. This nitric oxide is also not good because this nitric oxide, NO, nitrogen dioxide is NO2. This NO in presence of sunlight, you can see that slide now. Okay. I don't know whether my pointer will reach here. No, pointer doesn't reach, but I will show you. These are industries, these are power plants, and nitrogen dioxide, nitric oxide in presence of volatile organic compounds and sunlight give bad ozone. Bad ozone means what? Can anybody tell me what is bad ozone? Huh? No, you are just telling opposite. Bad ozone is the ozone present in the atmosphere. We require ozone to be present in what is known as the stratosphere. If ozone is there in stratosphere, it is good because it prevents the UV radiation coming from the sun. To prevents means it blocks and doesn't reach the earth. But if it is present in the atmosphere, it is not good. There are many bad effects. Now how, there are two things, listen. This nitric oxide, it converts oxygen present in the atmosphere. We require oxygen, isn't it? If some of our oxygen is converted into ozone, which is not good, so it is very bad. Okay? So nitric oxide, in other words NOx. When we say NOx means it contains both nitric oxide as well as nitrogen dioxide. These are the worst gases and maximum amount is coming from vehicles, then industries. Okay? So vehicles, there is a direct relation not only with this, even with the diseases which are formed because of this ozone, etc. So the place where there are more number of vehicles, there will be more nitrogen dioxide or NOx, and there is more ozone also. For example, Los Angeles in California has got the very large number of vehicles. Even Shanghai in China, Seoul in Korea, even Tokyo in Japan. These places, they have got very large number of vehicles. Now, that is why the proportion of nitrogen dioxide or proportion of NOx is very, very high in the atmosphere. Often schools are sometimes closed fully. The students are not allowed to go out on the playground. It is just opposite of what we do here. Why they are not allowed to go out? Because outside the classroom, the NOx level has gone high. There are indicators placed everywhere. If the NOx level goes high, then people have to wear masks and they have to isolate themselves in such a place where the NOx level is controlled by certain machinery or by certain equipments. Okay? So, this is the situation. So, NOx is very bad for two reasons. Number one, it causes pollution. NOx is brown in color. Nitrogen dioxide, nitric oxide is not. Nitrogen dioxide is brown in color. That is why in some of these cities, if you go, you can see brown haze in the sky at this particular time in the afternoon at about 3:30, 4 o'clock, etc. Brown haze in the sky, which is not there in Goa. Goa, or for that matter even Bombay, is much safer. Although Bombay there are so many industries and so many vehicles, but still we are safer. Can anybody tell me what is the reason? What is the reason? Trees, no. Trees could be one of the reasons, but trees take up carbon dioxide. They do not take up other gases. Nitrogen dioxide, coastal areas. Correct answer, coastal areas. But can you tell me what happens because of the coastal area? Which bridge? Can you be better specific? I will give you a prize if you tell me the correct answer. You have studied it. Say what happens in the morning, what is hot and what is cold, from where what comes and what goes. No, we are, you said coastal areas, that means we are close to the Arabian Sea. Okay? Yes, so don't worry, I will tell the answer. See, there is what is known as the land breeze and sea breeze every day, 2 times every day. See, right now the earth is hot. You can see the wind blowing from the Arabian Sea. You can see the leaves, how they are moving. It is rushing towards the land. Why? Because there is low pressure here. Hot means low pressure. Okay, something which is hot, there will be low pressure. If there is a low pressure, water is yet to get heated up. So, the wind comes here. Got it? So, that is called as the sea breeze. But after some time, the land cools very fast. After some time, when the sun sets, the land will cool. There will be high pressure here. Water is warm now. After some time, 6 o'clock, 7 o'clock, 8 o'clock, till night also, water is still warm and it doesn't cool that faster. Land or earth cools faster, and as a result, there will be high pressure, low pressure, and the breeze from the land will go. That is called as the land breeze. So, we have land breeze and sea breeze taking place almost all the time. That is why it takes away, because sea is very vast, and seas are then connected to the oceans. In fact, yesterday I read something, my friend had said something, that if you leave Gujarat at a particular point at a straight right angle without turning to the left or to the right, okay, you straight away reach Antarctica. No landmass comes in between. So, that is also surprising. No landmass comes in between. So, straight away reaches South Pole, Antarctica. Okay. Now, that is regarding. So, you have understood this. In between, if you have any doubt, any difficulty, you can ask me. Okay, we will proceed further. Now, this is a news. I am not going to. Over 90% of the world breathing bad air. See, we are least bothered about this. This is not recognized. People dying of pollution of air, you might have never heard of, because there is no direct report that so and so died of corona. Yes, there is report, so many people died of corona, but more number of people, more than corona, must have died because of pollution. That is not noticed, it is not recognized. Okay? So, pollution of air is very bad because the oxygen content decreases because of the pollution of air in the atmosphere. Goa, we are considerably safe, but we should not neglect, we have to take the precautions. Next slide is 2,500 people die daily due to polluted air, and by 1240, this number is going to still increase every day. 2,500 people are going to die. So it's a very bad situation. I will not discuss on this because, okay, you might have read in newspapers, etc. In Delhi during December, the situation is very, very bad because Delhi is a interior part, like Nagpur also, Solapur, Jalgaon in Maharashtra. These are interior places. To some extent, even Pune. Pune is also not good place, especially recently, because the number of vehicles have increased in Pune considerably, and the air doesn't go out like what we have in Goa or Mumbai, etc., because we are on the coast, west coast. Okay, so these places, they are not good. There are lots of problems. I will not elaborate on that. Okay. Here, these are some places. Those who are using Google Map, etc., they are aware of this. You can see those places. One is Punjab Bagh to the left side. Next is Anand Vihar. These are places in Delhi. Okay, Mandir Marg and RK Puran. This data is not now, this data is 2016, but now that situation has not improved, it must have worsened, okay, because number of cars have not decreased, but the number of cars have increased, and I doubt the number of electric cars have not increased to that extent. Once the number of electric cars increases, then the situation will start improving. People were saying that CNG, but CNG is also a petroleum product. It is a fuel. It is also a fossil fuel. What is CNG? Can anybody tell me the full form? Compressed natural gas. Yes, that's correct. See, now can you see those green figures? PM 2.5 should be 60 and PM 100, PM 10 should be 100. Those are called picometers. Okay, that means the particle size of the aerosols. If it is 2.5, then the limit should be 60. But look at the limits here in the, say for example, Punjab Bagh. Okay, the limit is the observed for PM 2.5 is 136. Okay, then this place is 363, the other place is 136 and 265. They are far beyond the standard prescribed limits, much above. That means they are not good for health. Particulate matter of that size, it goes right into our lungs and it affects the alveoli. Okay, so they are not good. Here I would like to show you one video. Volunteer, click on V1. See, in places like Seoul, Shanghai, many Chinese cities, and even now Korean cities, and even in Japan, what they are doing, they are removing the carbon from the atmosphere. Carbon is the major pollutant. From where the carbon comes from mainly from burning of fossil fuels. Okay, because fossil fuels are hydrocarbons. Burning of diesel gives more carbon than burning of gasoline. You must have seen, if a bus passes by, then there will be lot of smoke behind. If a car passes by, smoke is not much, okay, it is less. So diesel, burning of diesel gives more smoke or more particulate matter, that is carbon. Carbon is the major. So what they do, carbon causes further what is known as smog. Smoke plus fog gives smog. Water gets condensed on the surface of the carbon particles, and then in that water gases like sulfur dioxide, sulfur trioxide, nitrogen dioxide, they get dissolved, and when they get dissolved they form the corresponding acids. Nitrogen dioxide will form nitric acid, sulfur dioxide will form sulfurous acid, sulfur trioxide will form sulfuric acid. So these acids, they are there in the clouds, or that is called as a smog or aerosol. So that can come down at any time on our trees, bridges, monuments, etc. So that's not good. So yeah, this is the one video. They are sucking in the carbon dioxide, carbon particles.
We decided to build the largest smog vacuum cleaner in the world. So it sucks up 30,000 cubic meter per hour, cleans it on a nano level using very little electricity, and then releasing the clean air. So we have parks, playgrounds, which are 55 to 75% more clean than the rest of the city. Every month or so, it opens like a spaceship. This is the stuff we are capturing. This is Beijing smog. Pollution. This is the horror. We live 5 to 6 years shorter. Children have lung cancer when they're 6 years old. And we realize that 42% is made out of carbon. And carbon, of course, under high pressure, you get diamonds. Yes. So inspired by that, we compress it for 30 minutes and making smog-free rings. So by sharing a ring, you donate 1,000 cubic meter of clean air to the city where the tower is in.
Okay, what you saw now, that there are very big, they are like big towers, okay, huge buildings, like they are vacuum cleaners. So they take in all the carbon, whatever that is possible, suck in the carbon the way the vacuum cleaner sucks, and that carbon is then under high pressure converted into a diamond, and those diamond rings are sold to the public. Why? Because one who buys, it is not the actual price, but it may be slightly more than whatever that is. He is contributing towards making the air cleaner. So if you have purchased one ring which is corresponding to 1,000 cubic meters of clean air, that is what they have equated. One diamond ring prepared from that carbon is equivalent to 1,000 cubic meters of clean air. So if somebody buys that ring, that means you are contributing towards cleaning the city. So this is happening in many of the East Asian countries as well as some countries in Europe. There are no such type of vacuum cleaners in India so far. Okay, let's proceed further. Are we going to stop using motor vehicles because they cause air pollution? On the contrary, I have seen that people have more cars now than they were earlier. Okay, the number of cars increasing. Answer is no. Reasons are quite obvious. The population of people is increasing, and people can afford to buy vehicles due to the social and economic change that has taken place during the past 20 years. Are we going to close down power plants and industries because they cause pollution? This is like almost impossible, because there are so many gadgets coming from industries that we are using here even today, right now. Okay, so that is almost impossible. So what we should do if that is the case? What we should do? There are 3 R's that we should practice. reduce, reuse and recycle. Okay. The kits that you are going to use after some time make use of this principle, that is reduce the quantities, reuse the quantities as much as possible, okay, and finally you have to recycle them. Reduce and reuse cuts down the demand and restricts production, thereby decrease pollution. Recycle reduces the cost of production. All the 3 R's decrease energy consumption and preserve natural resources. Okay. I will not go through the next slide. I think we will stop here. How to minimize power and fuel consumption. Okay, let's not discuss on this because all of you are aware of it. Now we are going to start with the actual activity. The volunteers are going to distribute the kits to your table. Okay. The kits, we have removed the booklet which is present there inside because it may get spoiled unnecessarily, because I am going to be your booklet right now. So you are not going to follow the booklet and do the experiment. So I am going to tell you what to do. I am going to write certain things on the board. You have to follow accordingly, and please handle the kits properly. No, you cannot sit this way. You won't be able to see the board. That is why we have arranged them in this. You can join them if you don't mind, or any other table. You have to see the board. Okay. In this kit, right now what we are going to do is open the kit, and there is a bottle inside. Wash bottle it is called. So you take out this wash bottle first, open it. Listen here, those who are, there is a throttle inside, you have to fix it here. There is no thread, you have to just press it, okay, and fill some water into this, water from your drinking water bottle. Half the quantity, don't require full bottle, about half the bottle is enough, okay. So fill some water from one of your water bottle, yeah, that is enough. Close it, keep it ready. Okay. Number 2, you will require this paper packet. Okay. This paper packet, please listen here, look at me, listen here, don't discuss amongst yourself, then you will not be able to do the experiments. See, if you do the experiments quickly, we will be able to do more and more experiments. Okay. Otherwise they have told me, the organizers have told me to stop at 4 o'clock. Okay, so we cannot proceed further. Last time we proceeded up to 5 o'clock, so that's not possible today because you have come from far. Okay, so there are 3 things here. We are going to use only 2 of them. First is white paper, so you can remove it out. There are 2 lines on this, one vertical line and another horizontal line. So you have to just keep it on the table. We are also going to use this black paper, so you keep it on the table. We are not going to use this. In place of this, you will be supplied some paper, okay? Tissue paper will be given to you. Don't use this. The reason, it requires a lot of time for me to make this. So we are saving that time. Okay. Now, next step. We are carrying out reactions volunteer paper packet is not there. No, not that paper. That paper you can give afterwards, and give only one, don't give more. They require which paper? Tissue paper or the white paper? White and the black paper. Okay. Volunteer, please collect it from other kit and give it to them. That packet containing white, black paper. It's not there in your case also? Surprising. Here also 2. Okay. Now, next step is we are going to use this petri dish. Inside this petri dish, it is made up of plastic. There are 2 empty tablet containers. We are not going to use them right now, or we may not use also. You can keep them in the actual box, this box. Remove them, keep them in the box. We are going to use this petri dish. This is the base of the petri dish, this is the cover of the petri dish. Okay? Every time we are going to carry out the experiment, gases will be involved. These are gaseous reactions. So as soon as you add the chemical, and when I tell you, you have to quickly close it. Open it, put the chemicals or put the reagents and close it, and observe what is happening. Observation is a very, very important thing that all science students must learn. Okay? So this is your, you have to keep the white paper, on that white paper keep the petri dish. White paper, keep the petri dish, so that there is one vertical line, one horizontal line. Are you ready? Let us start with the experiment, first experiment. I will. Okay. Can you hear me? Yes, very good. This speaker is also going to trouble me. Yeah, slightly. Anyway, we don't require that screen right now. Enough. Okay, what I have done, I have just drawn your petri dish, the base of the petri dish. Okay. Now, you have to, okay, that part I will just show you first, and after that I will. Yeah, show me, give me that. No. Yes, no. Solutions, chemicals. And dropper packet. I will just show you once, afterwards you can do it yourself, there is no problem. See, you have to take the any vial which is required, there are labels on it and there are letters also put on the top. So you have to use the same dropper. If it is A, you have to use A dropper. A means bromocresol green, that is BCG. I am showing you how to use this BCG, or for that matter any other chemical. One of you will do this, your neighbor or your friend will give you the dropper and take out some quantity of BCG. It is green in color. This BCG indicator has got green color when it is neutral. When it becomes acidic, it is yellow in color. Okay, and when it is alkaline, it is blue in color. So very, very sensitive reagent. So you have to use it very carefully, and we require very, very less quantity. Don't add more. Where you are focusing? On me? No, Petri dish. I want you to focus on one of the Petri dish, either there or here. See, that is possible, or this. That is possible. Okay. Can you see? Give me the Petri dish here on this side. I am just showing you the quantity amount. I will return yours. Don't worry. I have taken some amount of BCG, put one on the vertical line, one small drop on the vertical line. Can you see how big I have put? And slightly bigger than that below. Dikhai deta hai na? Both are looking almost of the same size. So let me decrease this size. Okay. One is slightly bigger, one is smaller. Done? Come on, everybody should do that. Please go ahead. क्या करने का? निकालने का. Magic. Do it. After you add, okay, the remaining quantity should be transferred back into the vial. Okay, close it firmly. Keep this in its place. Keep this also in its place. Don't keep it anywhere else on the table. Before keeping it in this, you have to wipe the tip with the tissue paper provided. Wipe the tip and then keep it here. So take some quantity, put the drops in the Petri dish, remaining quantity transfer into the vial, wipe the tip of the drop tissue paper, keep it in the place. Everything should be kept in the place. Come on, start. Each one of you should get a chance. One experiment one of you can do, the next experiment you exchange your duties. Okay? So that all of you will get a chance. Yes, that is okay. Quantities are little more, but that is okay. Yes? Volunteers, please go to the tables and check whether they are doing the experiment properly or not. Volunteers, please go to each table and check whether they are adding the quantities properly or not. Both are big size, doesn't matter, let it be. Okay. Okay, the top drop, the smaller one is representing a tree. Okay, the smaller one is representing a tree. The bigger one is representing a lake of water. Now we have to see how this is getting affected. Now all of you, you travel somewhere and on the road, if there are trees on both the sides of the road, or on the sides of the road if there are trees, you will see that the leaves of these trees, they are normally not blush green, but they are yellowish green. This is because leaves lose water by transpiration, and at any moment there are some droplets of water on the surface of the leaf which are about to evaporate. Okay? So if cars, buses, vehicles pass by on the road, okay, they emit nitrogen dioxide and nitric oxide. These gases, they dissolve in this water and form nitric acid. If sulfur dioxide dissolves, it forms sulfurous acid. If sulfur trioxide, sulfuric acid. But cars do not give that much amount of sulfur dioxide and sulfur trioxide, that is negligible. They give mainly oxides of nitrogen. And that is the precise reason the leaves are not dark green and they are yellowish color. You are going to see that right now. What we are going to do now, we are going to put some vehicles in our petri dish. This petri dish is like a mini environment, okay? It's like a mini environment. You can consider, some students have come from Kutsade, so you can consider it's a town of Kutsade, or you can consider Talegaon or entire Goa also. There is absolutely no problem. Imagine everything is put there, so there are schools, universities, colleges, so many vehicles, so many lakes, so many trees are there. So they are going to get affected by this pollution. Okay, so we are putting now some vehicles inside. So what we are going to do? Okay, I'll tell you. Take the vial H vial. You have done this already. That is, you have put a small drop of BCG. And you have put a slightly bigger drop of BCG here. BCG means bromocresol green, that is A. Now what you do, take some quantity of H and put it here, a slightly bigger drop of H. Okay, this is H. H is NO2, sodium nitrite. So you have to put small quantity of H here, maybe 2 drops, because we have put some vehicles. This can represent vehicles as well as industries. Okay, everybody has done. Added H, NaNO2. At the center, it should be bigger drop. If 1 drop is not sufficient, you can add 2 drops, but not 2 large quantities. I can see on the screen that is a good quantity. Whosoever has added it, that is okay. Ready? Okay. Now your partner should be ready with the lid to close it, and you add to this F. You have to add F to this. I am purposely using different color. F is sulfuric acid, H2SO4. Please note that these chemicals are very, very high. Don't panic. On the top, without touching, on the central drop you have to add without touching it, and then close it immediately. You have to put it on the central drop, sodium nitrite drop, without touching it, and then close it immediately. Okay? Close it immediately. After adding the drop, close it. Don't block the camera. Yes. And observe now what is happening. See what is happening. Did you add sulfuric acid? Add to the central drop. Be quick. Take some quantity. Add 1 drop. Add just 1 drop is enough. Without touching. Dal diya? Okay. Remaining quantity transfer back. Wipe the tip of the dropper with a tissue. Place the dropper in its place. Place the vial in its place. Okay. What is happening? The color has changed yellow. Are you getting the yellow color? Okay, all of you are getting yellow color. That's what I told you in the beginning, that if the pH is 7, the color is green. If the pH is greater than 7, 8, 9, 10, etc., the color is blue. And if the pH is less than 7, the pH is less than 7, the color is yellow, that is acidic. This is acidic, this is alkaline or basic, and green means neutral. All of you got yellow color? Okay. Now, when we go in traffic areas, our eyes starts burning. You must have seen it sometimes when the traffic is very high. What is the reason? Because nitrogen dioxide present in high traffic or densely populated areas, or especially cities where there are high vehicular density, there is lot of nitrogen dioxide in the air which gets dissolved in the water of the eyes. Eyes are always watery and our eyes start, also water gets dissolved in the sweat and then it starts itching, especially in summer days. And when you are, if you happen to go to Delhi, definitely this is very common. Okay, it doesn't happen to that extent in Goa because we are on the coast. Okay, now if acidic waste is produced, suppose this was our industry and the gas coming out from this is NOx, that is nitric oxide and nitrogen dioxide, and that gas has dissolved in this and formed nitric acid. It has formed nitric acid. This has turned yellow, this has turned yellow. Now, if that is an industry and if industry has produced acidic waste, how do we dispose that acidic waste? What do? We neutralize the waste. Okay. So, do you know what is the chemical that is used in industry to neutralize the waste? We are not going to use the same thing here, but we are going to put a drop of, open the petri dish and put a small drop of ammonium hydroxide, that is G. Take vial G, ammonium hydroxide, NH4OH. Okay, yes, thank you. Add a drop of ammonium hydroxide and close it immediately. Don't keep it open. Drop on the horizontal line, small drop, and close it. And now see what is happening. Gas ammonia is going to come out from here. Ammonia gas. You can smell that vial G. Open it and smell it and see. Take your mask low. Smell, you will get the smell of ammonia. You will get the smell of ammonia. Okay, close it immediately. Don't keep it open. Ammonia will disappear. Ammonium hydroxide is gas ammonia dissolved in water. The color of the indicator yellow now, which was green earlier, has changed to blue, but observe, if you observe it carefully, it changes from blue to green and then changes from yellow to green and then to blue. See, it passes from this way and then it goes to blue, yellow to green and then blue. Next time you can see it properly. All of you got? Okay, don't keep the petri dish open, let it be closed only. You are going to make a very interesting observation. Okay, listen here carefully. What you do now, you take that black paper and put it below the petri dish, above white paper, below the petri dish. You can lift it and keep it. Above white paper, below the petri dish, and observe at the center. You will see a sort of aura here around this central drop. That is called aerosol. Don't see from the top, see at an angle. In fact, I can see this from here, you can see it on the screen also. Outside that drop, you see very fine, they are very fine solid particles dispersed in air. That is called as an aerosol. Similar type of aerosols are formed in nature. See, this is quite good. You can see it here. Kuch gadbad?
Sir, where this less? Should I put in little less? Is this less? This amount?
No. Hey, there is. Okay, put more and check. G. Put G more, or you can put one more drop on the other side. Don't keep it open. You people keep it open. You have to close it immediately, because these are gases. No, all the reactions take with gases. We are not adding directly to the indicators. Indicators react with gases. Okay. Yes. So that's called as an aerosol. Aerosol means very fine solid particles dispersed in air. This appears to be better comparatively. I don't know. This is also good. This is also good. Very good. Very good. This one is good. Quantities should not differ. You have added so much of quantity. You are getting the aerosol, but quantities are too large. Okay. Now we have completed one experiment, and I will show you what is to be done after completing one experiment. Okay, let me show it here. You have to wash the petri dish as well as the lid. What you do, you take this wash bottle and squirt some amount of water here in the petri dish. Okay, as well as the lid, both are to be washed. This is leaking, I don't know why, don't worry. It is simply plain water, and you have been given waste cup, no? So wash it twice, don't wash it once more. Put some water, swirl it, take all that waste, put it here. Lid also, both are to be washed. Then you have been supplied with the tissue paper. Wipe the petri dish lightly, not vigorously. Just wipe the water and keep it ready for the next experiment. Meanwhile, we can have a cup of tea. After this experiment, we'll have a cup of tea, and then we'll go to the next experiment. Okay? If there are any questions, you can ask. Any questions? Teachers also, yes. Yes. Instead of exactly the same gases are produced here. Only instead of vehicles, we are putting a chemical here. That is the difference. Okay? We are not putting vehicles inside, but we are putting a chemical which generates the same gas. Chemically, it is the same gas. It is the same aerosol, but the aerosol formed there is slightly different, because it is the carbon particles, rubber particles, dust particles on which water gets condensed, and in this water, those nitrogen dioxide, sulfur dioxide, etc., these gases, they get dissolved. Okay. Sometimes, these clouds may contain tons of acid. Yes, especially in industrial areas. Okay. You have not answered one question. Is the tea ready? Volunteers. Is the tea ready? Not yet. So, it is served. No? You are going to serve it to the participants, or only to resource person? I want badly. Yes, you are absolutely right. Actually, while leaving my house, my wife said tea is ready. I said no, I want to go. and I will get a tea there. Students also. म्हाका एक दी पळय पयलीं. Okay, you'll have to have your tea quickly, those who wish to, and then join for the experiment. Your question is answered? Yeah. Okay. Don't hesitate to ask questions. Students normally have lots of questions, but they don't ask. Why? They get scared because their question may be wrong. Somebody may laugh at you. Will not. Don't worry. If you have questions, please ask. Given already. No, not served, but I have given the tea break.
Okay.
First experiment is over.
The mic.
Mic.
Students, may I have your attention? Table wise, you can go and have tea. Tea is come over here. One table at a time, please. You can go and have tea.
Finished? Time is running fast. We have to do 2 more experiments. So, are you ready? Okay, attention please. We will start with the next experiment. In this experiment, we are going to generate sulfur dioxide. Okay? So keep the white paper. On the white paper, keep the clean base of the petri dish. So you have vertical line and horizontal line. This is your petri dish. As before, put small drop of BCG here, that is A. Pull slightly bigger drop of BCG here, that is A. On the vertical line, everybody has done? BCG. Transfer the remaining quantity back into the vial. Close the vial firmly, keep it in its place. Wipe the tip of the dropper. Done. Now at the center, we are going to add E, vial E, that is sodium sulfide, Na2SO3. put slightly bigger drop, 1 or 2 drops at the center. Put 1 or 2 drops of E at the center. Just 1 or 2 drops. Done? Okay, be quick. We have to finish this experiment fast and we have to go for the next experiment. Okay? On the top of this, you are going to add F, that is H2SO4, on the top without touching it. Open, add the drop, only 1 drop is enough. Small drop of H2SO4 and close it immediately. Sulfur dioxide gas will be generated from here. That sulfur dioxide gas will get dissolved in this and form sulfurous acid. It will get dissolved in this and form sulfurous acid. The color of the indicator is going to become yellow. Slowly, it changes at the periphery first, then at the center. Are you getting, everybody? Volunteers should, after having your tea, should check whether they are getting the change. Are you getting? Say yes, no? Ah, very good, very good. Okay. क्या हुआ? Why you have not closed? खुला करके कैसा होगा? Gas will escape out. These are gaseous reaction. The sulfur dioxide gas dissolved, formed here, should get dissolved into this. If you keep it open, the gas will escape, and moreover there is fan here above you. Okay. Now it has already gone. So what we will do? We will add little bit of, open it. Close it. You have to immediately close. Okay? Don't wait. Changing now. सल्फ्रिक एसिड डाला है या नहीं? डाला है ना? और थोड़ा डालेंगे क्योंकि आप लोगों ने खुला रखा था. नहीं, बाद में नहीं, खोलने का ही नहीं, गिरा नहीं. हाँ, क्लोज इट. अब हुआ ना? हाँ. सो आपने सल्फ्रिक एसिड बराबर नहीं डाला था और खुला रखा था, इसलिए नहीं हुआ था. एवरीबडी इज गेटिंग? वेरी गुड. So this is exactly like previous experiment, only the difference is that we are getting sulfur dioxide gas. Sodium sulfite Na2SO3 plus H2SO4 gives sodium sulfate Na2SO4 plus H2SO3 sulfurous acid. Sulfurous acid is unstable. It decomposes into sulfur dioxide and water. Okay. So that sulfur dioxide gets dissolved in the aqueous portion of the BCG indicator and it forms sulfurous acid. So the solution becomes acidic. That is why you are getting yellow color. Got it? Okay. Now, like before, you are going to put a drop of ammonia on the horizontal line. Put small quantity, don't put large quantity. Okay? Put small quantity, 1 drop of ammonia on the horizontal line. put a drop of ammonia here. That is G, ammonium hydroxide. It is written there on the vial. So a drop and close it immediately. Those girls, don't keep the petri dish open. Put a drop, close it. You can imagine from a drop how much of gas will come out. You know, very little quantity, and if you keep it open, it will disappear. It will not give the result. So now the ammonia gas from here, ammonia gas will come out. NH3, and this will get dissolved in this. It will get dissolved in this, and it will form, it will neutralize the acid. Once the acid is neutralized, it will make it alkaline. So if you observe it carefully, the color changes from yellow to green first, and from green it becomes blue. All of you got blue color? Okay. Now, like before, you will have to put the black paper below the petri dish and above the white paper, and observe the aerosol formed at the center. Aerosol formed at the center. You can see on the screen there are aerosol means very fine solid particles dispersed in air. So you get it at around the central drop. Okay. Okay, so once you observe the aerosol, this particular experiment is over. We will go for the next experiment. Okay, so yeah, aerosol you can see. Then wash it like before, both the petri dish as well as the lid. Wipe it with the tissue. If you want more tissue, you can ask the volunteers, they will give you. Volunteers, please check if they require some more tissue. And finally, don't throw the tissue anywhere, keep it on the table. Okay, I will give you a waste paper basket, you can put them afterwards in that. Yeah, please see that they have tissue to wipe, but don't give too much of tissue, because tissues are made of trees. More tissue we make use, more trees are to be cut. So we should minimize the use of tissue. Okay, are you ready? Okay, let us start with the next experiment. Now you just put only one small drop of BCG, don't put two. Okay, A on the vertical line, BCG, only one drop, small drop, as small as possible, which you can just see on the vertical line on the top, the way I have drawn on the board. Okay, done. Transfer the remaining quantity back into the vial. Transfer the remaining quantity back into the vial, close the vial, wipe the tip of the dropper with the tissue. Wipe the tip of the dropper with tissue. Done? Okay. Now, see, I will just explain you for a minute. The nitrogen dioxide, which is coming mainly from the vehicles, is very dangerous for the several reasons. There are three main reasons. Number one, itself is a very bad pollutant, and you know, all vehicles using fossil fuel, that is gasoline and diesel, okay, are producing this nitrogen dioxide and nitric oxide. Got it? Okay. Now, I told you some time back that nitric oxide is also responsible for the formation of ozone in the atmosphere, which can even cause cancer of the skin, and there are so many problems related to ozone in the atmosphere. Where the number of vehicles are more, ozone is also more. Got it? Now, the third reason why nitrogen dioxide is not good, because nitrogen dioxide oxidizes sulfur dioxide to sulfur trioxide. Got it? Sulfur dioxide is somewhat okay, but sulfur trioxide is not. Sulfur dioxide gives sulfurous acid. Sulfurous acid is unstable. It gets converted back into sulfur dioxide and water. But once sulfur dioxide gets oxidized to sulfur trioxide, it forms sulfuric acid, and once sulfuric acid is formed with water, it forms sulfuric acid. With sulfur trioxide, it forms sulfuric acid. So once sulfuric acid is formed, there is nothing you can do, so that is not good. So sulfur dioxide oxidizing to sulfur trioxide is because of nitrogen dioxide. So nitrogen dioxide acts as an oxidizing agent. Okay, now I am going to ask you a question, and it is also a prize winning question. Who can tell me what is oxidation? There are three different ways you can answer this question. What is oxidation? Addition of oxygen. Okay, I will not give you the prize. I will give the prize only for who answers the question. Third answer, gives me the third answer. One way addition of oxygen is oxidation. Okay, what is the other definition? Huh? I am asking you what is oxidation. That is not, that is the oxidation of a metal. Yes. Yes. Huh? Loss of electrons. Yes, good. Loss of electrons. And for giving the prize, you can take his. Okay. What is the second definition? You have not addition of oxygen. Removal of hydrogen. Okay, good. So all the three definitions of oxidations are answered. So we are going to do one oxidation reaction here. Okay, and what you should do, put a drop of small drop of this is not good. This is not good. I, dropper I, that is starch Ki, starch Ki, vial I, Hi. Take a dropper I and put a small drop, don't put big, very small drop of I on the horizontal line, either to the right or to the left, any side you can use. Done. Transfer the remaining quantity back into the vial, close the vial firmly, keep it in its place, wipe the tip of the dropper and keep it in its place. Done? Okay. What we are testing? We are testing the oxidizing property of nitrogen dioxide. So at the center, we have to generate nitrogen dioxide. So we are going to add here H, that is NaNO2. H, NaNO2. At the center, one drop, slightly bigger, or 2 drops. At the center, put 1 drop. If it is less, then you can add 1 more. Yes, add 1 more. Enough. Close it. Transfer the remaining quantity back. Done? Okay. Now on the top of this, you have to add F, that is H2SO4, and close it on the top of the central drop without touching it. Without touching, you have to add sulfuric acid, F. On the top of the central drop without touching it, and close immediately. Those girls there, you had not closed last time. Please see that you close it immediately. The moment you add the drop, you have to close it. Otherwise, the gases will escape out of the petri dish. Okay. Now, what will happen? The nitrogen dioxide gas is going to come out from here. NOx is going to come out, NOx. This NOx will get dissolved in this. NOx will get dissolved also in this, and it is going to oxidize. See, at present your starch solution is colorless. Okay. Why it is colorless? Because it is containing potassium iodide, K plus I minus. That is not giving any oxidation. Now that girl answered that loss of electrons is oxidation. So here if I minus, if 2I minus loses 2 electrons, minus 2 electrons, it will give 2 iodine atom, which is equal to iodine molecule. Iodine molecule can nicely sit inside the pyranose structure of the starch molecule, and which can absorb in the visible region. The complementary color of that is blue. So you will get a blue color in the starch solution. Are you getting blue color? Starch solution, Ki is turning blue. Is the BCG indicator turning yellow? Done? Okay. One more experiment. I will show you one more experiment, and in this case, listen here. All of you got the results. Is there anyone who did not get the result of this particular experiment? Okay. One more experiment, Ask. Is Sandesh there around? 1 or 2 more experiments till you are getting ready. One more. 15 minutes. Okay. 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 So I will explain you the experiment first. Try to understand what is the experiment about. Okay? Then I will make a small demo here, and after that demo you can do that experiment yourself. Okay? So, sometime back I mentioned to you that in industrial areas, especially those industries which are making use of raw materials containing sulfur. Okay, the sulfur is not coming from fossil fuel, If you happen to go to Zuari Agrochemicals, there is sulfur dioxide produced, especially coming from naphtha. Naphtha is a raw material which does contain sulfur. They do remove sulfur, but complete removal is not possible. Some amount of sulfur does remain, and that sulfur gets oxidized to sulfur dioxide and then sulfur trioxide. So, at Zuari Agrochemicals, they produce what do they produce? They produce fertilizers, and the major fertilizer produced is urea. Okay? Urea is CONH2NH2, and that is produced by making use of naphtha, which is cracked to give carbon monoxide and hydrogen, and then ammonia to give finally urea as the major product. Okay. So, there sulfur dioxide is formed and sulfur trioxide is also formed. So, the most of the industries which make use of raw material containing sulfur will give sulfur dioxide. Most of the ores, iron ore, copper ore, okay, they may contain sulfur, and if they contain sulfur, that gets oxidized to sulfur dioxide and sulfur trioxide. There are methods to decrease the sulfur dioxide going into the atmosphere. There are what are called as Cottrell precipitators, by which you can remove considerable amount of sulfur dioxide going to the atmosphere. But still some amount of sulfur dioxide goes into the atmosphere. Okay? And it goes into the cloud. Cloud, in a sense, I mentioned to you aerosol some time back. So, it gets dissolved in those droplets and forms. Finally, it gets oxidized with nitrogen dioxide. Just now I have shown you that sulfur dioxide is getting oxidized, and then it is there in the cloud, and lot of sulfuric acid is there in the cloud. We are going to do the same thing right now here. That means we are going to generate one cloud in the Petri dish. Okay? So, I will explain you the experiment and I will generate you. Don't do. First listen to me, see what I am doing, and then you can do it by yourself. Okay? I will go to the board first. I will have to draw a little smaller because I have to draw two things here, and our board is small. This is one Petri dish, lower portion of the Petri dish. Is it okay? Can you see it? Can you see? Okay. And this is the lid of the Petri dish, the top portion that we put on the top. Okay? Don't do anything, just keep them aside. I will tell you when to do and what to do. Now, here as before, you are going to add just one drop of BCG. Small, don't add right now. I will tell you when to do that. Small drop of BCG in the base portion. This is base of the Petri dish, and this is the lid of the Petri dish. LID, lid of the Petri dish. We are going to generate how is that they are not working properly. You brought new ones, no? Okay, thank you. Now, don't do it, I will tell you when to do. At the center, we are producing sulfur dioxide gas. We have put a factory here. So, we are going to add E here. Don't do, I will tell you when to do. That is at the center, on the top of which we are going to add F. Before doing this, we have to make a cloud here, cloud in the Petri dish lead, which will remain on the top. I will show you how to do that cloud, and that cloud is which? With K. K is hydrogen peroxide, H2O2. It is just 2%, 3% solution. Okay, let me explain you. See, in the atmosphere, there are lots of peroxides, different types of peroxides. Peroxides means what? They have got O-O linkage. Hydrogen peroxide is H bond O, then bond O, and then hydrogen. That is hydrogen peroxide. You can have metal peroxides, you can have alkyl peroxides, different types of peroxide, and they are formed by photochemical reactions, and they also decompose. That means the peroxy linkage is broken. That is broken in the same way, that is one electron going to oxygen and another electron going to the oxygen, and you get radicals. These radicals are responsible for a large number of unwanted bad reactions in the atmosphere. So, this hydrogen peroxide which is there acts as an oxidizing agent. It acts as an oxidizing agent. Now, what we are going to do is generate sulfur dioxide here. Sulfur dioxide is going to come out from this. That sulfur dioxide coming from the industry will go into the cloud. That means this lead we are going to put on the top. I will show you how to do that, and all of you are going to do it, and all of you will observe this. Okay? So, this lead you can put it on the top with the cloud on the top. It's not going to fall. That sulfur dioxide generated in the industry, it is going to go into that cloud. Once it goes into the cloud, the hydrogen peroxide present in the cloud will oxidize it to sulfur trioxide. The moment it is oxidized to sulfur trioxide, it will form sulfuric acid, because all these solutions are aqueous solutions or solutions made from water, very dilute solutions. There is a lot of water. So, it will form sulfuric acid. Now, how do we know that sulfuric acid is formed? So, if I take the lead and add a drop of barium chloride to that, you will get a white precipitate of barium sulfate. Okay? This is the explanation. If you have any questions, you can ask me, and then we will start with the experiment. I will tell you what to do first. Any questions? Shall we start? Okay. So, first let us generate the cloud. Okay? Or you can also add here, but do not generate sulfur dioxide. So, this is a base, put a drop of BCG. Base of the Petri dish, lead is here, and lead you have to keep ulta. The way you have kept the base, the same way you have to keep the lead. Okay? Not that way. I will show you. Okay, this is your base. Here you have to put BCG, small drop first, vertical inside on the vertical line as shown there, left hand side. Base I have shown here. Small drop of BCG on the vertical line. Done. After that, you have to put I will show it here. K de do. K is hydrogen peroxide. See, I am taking out little quantity of hydrogen peroxide in this, very small, because you know this petri dish is entire Goa, I said. So you can imagine a small cloud. Put one small drop at the center of this. Done? Don't wait. I will show you. Don't do. I will show you first. Open this. Transfer this back. Close it. Wipe it. Okay, I have put a drop. Now don't be under the impression that this cloud is going to fall, but don't tilt it. Tilt नहीं करने का, ऐसा ही पकड़ने का और ऐसा करने का. देखो, it is not going to fall. Can you see the cloud? Can you see the cloud? This will be on the top of the factory which we have put, that is going to generate sulfur dioxide. So we are going to put this cloud on the top of the factory. The drop will not fall down. That is the advantage of plastic petri dishes. It has got a very high surface tension. So made the cloud. Yes, he has made the cloud. Now wait, we have to generate the gas and then keep the lid on the top. Kitna dala? Is that your cloud? Remove some quantity. Remove some quantity. Very good, very good. Now try making it like this. See if you can hold it in your hand and turn it. Very good. You can keep it like that also. It's not going to fall. ये तुम्हारा है. It's not going to fall. This is your cloud. Okay? Are you ready? Now add E at the center. E at the center of the base. Cloud is aside. Keep the cloud aside. You can keep the cloud ulta. Okay, so that you can close it immediately afterwards. Keep the cloud ulta. Kiya already. Added both. Okay. Now don't open it. Don't open. Don't open. Kya F? Afterwards E, then F. And then this is not the way you should hold it. That will fall. Hold it like this and then turn it this way. See? No, it's not going to fall if you don't do it that way. Add F and then close it with the cloud. Enough. One drop is enough. Okay. One drop is enough. To the cloud kitna bada tha? That cloud should be small one, and you did not do it properly. Small cloud. Where is the cloud? Is this? Okay. Put E there. F. First put E. How we are going to generate sulfur dioxide? Just now we have generated sulfur dioxide, no? So don't keep anything there. Everything should go into the first E. Dikhai nahi deta? Too far? You are sitting far. How you will see? You should have come closer. Yes. E and then add F to that and then close it. Come on. This is F you are adding, no? Without touching. Nahi. I have not seen. Add more. There is no F. Yes. Everything is correct. Don't worry. Now, the sulfur dioxide formed has to go into the cloud and it will get oxidized to sulfur trioxide. Whether it is oxidized or not, that we will come to know. So we have to do one more experiment. Double क्या दिखता है on the camera? Where is the camera? what is that? Cloud is there on the top. Okay, okay. Cloud is there on the top. See, one thing is true, that you are getting yellow color, that means sulfur dioxide is formed. That yellow color is because sulfur dioxide has dissolved and it has formed sulfurous acid. Now that sulfur dioxide has gone into the cloud. How do we know that sulfur dioxide has gone into the cloud? Because in the cloud there is hydrogen peroxide. It is going to get oxidized to sulfur trioxide, okay, and it will form sulfuric acid. And if it forms sulfuric acid, H2SO4, that means there are two H plus ion and one sulfate radical, SO4 2 minus. So that sulfate radical is tested by barium chloride. So if we add a drop of barium chloride to the cloud, then it will give a white precipitate. Listen, don't do. There are two precautions you have to take. Number one, remove out the lid and keep it on a black paper. There should be a black paper, because otherwise you cannot see the white precipitate. Keep it on a black paper. Ulta. Remove, keep it on the black paper. Done? Now, listen carefully. To this you will have to add a drop of J, barium chloride. But as soon as you get, your partner should be ready with a wash bottle. As soon as you see white precipitate, sprinkle some water on that immediately. Otherwise it stains the petri dish. My petri dish will get spoiled. Got the point? It gives a mark on that, white mark remains there. Once you see, not immediately that way, you must see white precipitate. So add J, a drop of barium chloride. As soon as you see the white precipitate, you wash it. J is here. Just one drop. Puro. That's enough. Then wash it. You got white precipitate, no? Very good. You got white precipitate? Yes. You got white precipitate? No. I can't see anything. Something is wrong. Experiment. Hey, क्या कर रही है? J added और add करो. No. What was this cloud from K, no? No, there is no white precipitate. All are getting. Okay. Tissue. Is there anyone who is not getting white precipitate? As soon as you get white precipitate, wash it with water. Don't leave it. Okay. Where is the white paper? Why you are not using the white paper? You have to use the white paper. That is a grid. That is called a grid. Now the first thing, you have to add the BCG indicator. Go on giving me the things which I asked for. Then give me K. Keep this back. Give me K dropper. This is the lid. Keep it on the white black paper. Okay. K. Okay. So I have added cloud in the atmosphere. Wipe this, keep it. Now I am going to generate sulfur dioxide. Give me E. So I have added E at the center. Okay. Keep this, keep this. Now give me F. F. is sulfuric acid. Now अभी ये उल्टा रखने का ऐसा, okay? And now as soon as I put this, you close it. Yellow, changing to yellow. Wait for a minute. Open right now. You won't get the result. Because sulfur dioxide has to go into the cloud and it has to get oxidized to sulfur trioxide. That takes some time. Okay? Put this back. Yes, are you getting? Where is the cloud? Now you have to remove the cloud and keep it here and put a drop of barium chloride on that. J. You are getting a white precipitate. Just check, put a drop, just a drop. नहीं होता है, done but not so good. Not so good. Got, but light, comparatively lighter. Are you getting? You got? Okay. You are getting? Okay. Are you getting? You got white precipitate. Okay, very good. All of you got? All of you got. Very good. Okay. Now add a drop of barium chloride on that. Yes. See now. You got a white precipitate. Okay. Now wash it. Don't keep it for a longer. Okay. Now there are many more experiments, but we do not have time. We will stop here. Okay. What you can do now, I will show you how to pack this. First check that you have put everything here. Now this is not. A is not here, and see that they are vertical. That means the letter is facing you. Turn them so as that letter is facing you. F is inverted. Turn it so that letters are facing you. H can be faced on both the sides. I also, but not J. Okay. K. 12. A is here. कितना use किया है तुमने? I hope you have not drank it. We can use it for 50 experiments. पढ़ले सगळे कशे? मस्ती करूंक नाही ना हांगा. Okay, once you have done this, put all the vials, keep them, remove the straw. There should not be anything in the box. Keep this. Once you have kept it, press each one and check that the lids are closed properly. Press them thoroughly and check lids are closed properly. Now take the clean petri dish. Okay, in that petri dish, put the empty tablet containers. We have not used them today. Okay, because we were not having sufficient time. I have put the 2 tablet containers, close it, keep it here. See, this is the way you have to close. After that, you have to close the dropper packet. Dropper packet, hold it this way so that you see A, B, C, D, E, F and put it on the left hand side. Done. Now you have to empty this. Volunteer, get that bucket from my stall. There is a small bucket there. You can pour this water into that bucket. You remove it and keep it out. And get the empty bucket and collect the waste water from them, because they have to empty this. You have to empty this before we close it and put it inside. See, you have to empty the wash bottle. Empty. Okay, then this throttle is to be put inside and close it, and then keep that one in the box. Volunteers, please help them to pack it. This straw should go at the back behind the vials, and then this is the syringe that we have not used. It will go here, and then paper packet. Where are the tissues from here? अरे तुका ते यूज करू नका म्हणून सांगिल्लें मरे. मस्तेपणा करतात तुम्ही जाणा मरे. That is the result. You are not getting proper results. Okay. Please, I will help you if you have any difficulty in packing it. This should be like this. Tablet containers. Where is this straw? Okay. See, if these are not closed properly, they may leak inside, and if they leak, everything gets spoiled. Okay. दो हो गया. हाँ? No problem. Where is the spatula? वो नीचे नहीं रखने का, ये ऊपर ही रखने का, इधर. हाँ, paper. Where is the packet? And where are the tissues?
Students, kindly be seated. We'll be
Collect all the
closing
kits.
down.
Please wait.
Dviti, kindly do the honors again. I request Dr. Diptesh to present a token to Ms. Varda Damle. On behalf of the organizers of Vighyan Sarvatra Pujyate, I thank all the teachers and students for specially coming over here and attending this one-day session. Students, please, students and teachers are requested to please attend or visit the stalls.